Hello, everyone. My name is Jiaxin. I am currently an assistant professor in the Department of Computer Science and Technology. Today, I want to introduce our research on adopting zero trust security in cloud environments. So nowadays, there is a widespread adoption of remote or hybrid work models across many organizations. So this makes the remote work outside traditional office settings a new trend worldwide. So according to a recent study, it shows that 40% of US job seekers actively prefer the fully remote roles, while 33% seek hybrid arrangements. So under this trend, bring your own device, or we call it the BYOD, plays a growing role. So employees can use the personal devices to access the organizational services from home or public environments. Although the remote workers typically connect via VPN softwares, but this setup greatly amplifies both the technical and human activity risks. So due to the untrusted networks and uncontrolled environments. So the key question here becomes, can we still trust the users after logging? So to address these challenges, people put forward the zero trust architecture. So its core idea is never trust, always verify. So this means every access request must be continuously authenticated and authorized. So it also enforces the least privileged access, ensuring that users can only access what they are allowed to. So actually, many cloud systems implement zero trust using the networking solutions. So for example, we have Calico, Cilium, Entry, or Router. So they often combine with the encryption mechanisms to secure the communication. So in our preliminary work, which is mainly conducted by my student, Landy Jimenez, we performed a comparative study to evaluate these existing solutions. So we measured the network performance, including TCP and UDP throughput, as well as the CPU and memory usage. So our results shows that while zero trust mechanisms improve security, but they introduce noticeable performance overhead. So for example, according to the figure here, as you can see, enabling encryption leads to reduced throughput and increased CPU consumption across all tested systems. And also, these existing solutions are not optimized for the remote work environments. So to address this limitation, we proposed a new solution called ConZ, so which stands for Context-Aware Zero Trust Framework. So the key idea of our solution is to incorporate more contextual information into access control decisions. So instead of relying only on identity verification, so ConZ evaluates additional factors. So for example, the device status, network conditions, and the user's physical environment. And in addition, many of these context checks and policy decisions are performed locally on the user's device, which helps reduce the unnecessary communication and system overhead. However, even with our improved design, the zero trust enforcement still introduces the processing overhead due to this continuous policy evaluation design. So as the future work we are planning to do, so we are going to leverage the SmartNIC-based hardware acceleration solution to offload these operations. So by moving the policy enforcement from the CPU to another dedicated hardware, we expect to achieve lower latency, reduce the CPU usage, and the better scalability for large-scale cloud environments. So these are all the brief introduction to our research work. So thank you for listening. If you have any questions or would like to learn more about our work, please feel free to contact me by email. Thank you.